Okay, in this video we are continuing to look at gas laws practice number 2. Question number 5. When using Avogadro's principle, the molar volume of any gas at standard temperature and pressure, we also say STP, which is 0 Celsius and 1 atm, is 22.4 liters. 1 mole of a gas contains Avogadro's number of particles, and we know from our previous unit 2 that Avogadro's number is 6.02 times 10 to the 23rd particles. So Avogadro's number of particles. To find out the volume of a number of particles, multiply the number of moles by 22.4 liters. So all this initial part has just been explaining how to do this problem. Then it actually gives us the problem. It says determine the volume of a container that holds 2.40 moles of a gas at STP. So the clue word here is this at STP part. We have to have this at STP to be able to use the molar volume of a gas, 22.4 liters. If we don't have that STP, then we cannot use the 22.4 liters. But since this gas is at STP, 22.4 liters is equal to 1 mole, or 1 mole of the gas fills 22.4 liters. So all we need to do to solve this problem is dimensional analysis. We start with 2.4 moles. We can put it over 1 if that makes us happy, times moles goes on bottom, and liters goes on top. And then 1 mole, 22.4 liters. And all we're doing, these moles cancel out. All we're doing is multiplying 2.4 times 22.4. Probably the easiest gas laws problem you've done so far. 53.76 liters. Alright, let's look for that on the answers. 53.76 liters is very close to 54 liters, which is letter A. Okay, number 6. What size container do you need to hold 0.0459 moles of nitrogen gas at STP? So once again, this at STP tells us that we can use molar volume of a gas, 22.4 liters equals 1 mole. So since we see this, all we need to do is dimensional analysis. 0.0459 moles, and then we're going to put it over 1 to make us happy, times moles goes on bottom, liters goes on top. 1 mole, 22.4 liters. So then all we need to do is type this into our calculator. 0.0459 times 22.4 gives us 1.028 liters. Moles cancels out. So looking for an answer that's close to 1.028. 1.03 is very close, so the answer is letter C. This next problem, what volume will 1.02 moles of carbon monoxide gas occupy at STP? So once again, we're at STP, meaning we can use molar volume. Even though it's a different gas than the last problem, we can still use 22.4 liters equals 1 mole. So all we need to do is dimensional analysis. 1.02 moles times, put a conversion factor, moles on bottom, liters on top. 1 mole is 22.4 liters. Moles are going to cancel. So we get 1.02 times 22.4 gives us 22.848 liters. Looking for that answer, 22.8. Here it is, letter B. Alright, this next one. Number 8. How many moles of nitrogen gas will be contained in a 2-liter flask at STP? Okay, so once again, we have a gas at STP. Sorry, my question moved. At STP, so we know we can use 22.4 liters equals 1 mole. The only difference here is instead of giving a number of moles, we're given a number of liters, and we need to convert it to moles. So instead of starting with moles, we start with 2.00 liters, put it over 1, and then we put liters on bottom this time, and moles on top. course, 1 mole is equal to 22.4 liters. So instead of multiplying this time, we're dividing. 2 divided by 22.4 gives us 0.089 liters cancels out, and we're left with moles as our units. So let's look for the answer that matches this. 0.089. 0.0893 is very close, so that is our correct answer here. Okay, in this last problem, it says if a balloon will rise off the ground when it contains 0.0226 moles of helium in a volume of 0.460 liters, how many moles of helium are needed to make the balloon rise when the volume is 0.865 liters? Assume that temperature and pressure remain constant. Okay, so in this problem, temperature and pressure are remaining constant, meaning we don't need to worry about them, but to figure out how many moles go with the new volume, we can't use 22.4 liters because it does not say STP. There's no STP listed in the problem. We're at a temperature and pressure other than STP. So because it doesn't say at STP, we have to assume that it's not at STP. So instead of using 22.4, we are going to have to relate the number of moles to the volume. So if you write out your gas law, PV over NT, we need to relate moles to volume. And I'll do this in a different color so it's easier to see. We need to relate moles and volume. So by doing that, we get the relationship of V over N, V1 over N1 equals V2 over N2. So the initial volume over the initial number of moles equals the final volume over the final number of moles. So we just need to look at the problem and identify these variables. So the balloon initially contains 0.0226 moles, so that's our N1, and a volume of 0.46 liters. So there's our V1. How many moles of helium, so we're looking for N2, are required when the volume is 0.865 liters. There's our V2 value. Our volume units are the same, and our new number of moles is going to come out in moles, of course. So all we need to do is substitute in our numbers. So V1, 0.460 liters over N1, which is 0.0226 moles, equals V2, 0.865 liters over N2, which we don't know what N2 is, so we're going to substitute in X. So now let's cross multiply, and I'm going to get rid of my units. So 0.460X equals 0.0226 times 0.865. 0.0226 times 0.865. That gives me 0.019549. Notice I'm not rounding here because I don't want to wind up with a rounding error. So last but not least, to isolate X, I'm going to divide by 0.460, and I'm going to do that on both sides. So these cancel out. We're just left with X equals whatever this division problem is. So this divided by 0.460 gives us 0.0425 moles. So let's look for that answer up above. 0.0425 is letter C exactly. So that is our answer to number 9.